Good afternoon, everybody. Now I'm going to present a video, give a presentation on e-content prepared as a part of task given in the training, learning-centric approaches. I have prepared a video based on physicochemical treatment of water and wastewater, which is a 5th semester course, and chapter 3, sedimentation. And I'm going to explain how to find the optimum dose of a coagulant using jar test. Now, before that, we have to understand the concept of settling. Now, what is settling? It is a solid liquid separation process, and it produces two outputs. That is, one is the clarified liquid that flows out of the sedimentation tank, and the sludge which gets deposited in the bottom of the tank. Now, why the settling is needed? The purpose is to remove post-dispersed phase, which will reduce the turbidity, and to remove the coagulated and flocculated impurities, to remove precipitated impurities after chemical treatment, and to settle the sludge after activated sludge process or trickling filters, which is a biological treatment. Now, the principles of settling is that the suspended solids, because of its weight and because of having its specific gravity greater than that of water, it will settle down due to gravity. So, if the water is brought to rest, the suspended particles in it will settle down. This is the principle of settling. Now, the theoretical average time for which the water is detained in the settling tank is called the detention period. Now, which all forces are acting on a particle suspended in water? There are 4 types of forces. One is the gravitational force, second is the buoyant force, third is driving force, and fourth is the drag force. Now, the gravitational force is acting in downward direction, buoyant force is acting in upward direction, driving force is acting in downward directions, and drag force is acting in upward direction. So we have two forces acting in downward direction and two forces acting in upward direction. Now there are 4 types of settling. So all these 4 types of settling happen simultaneously. So let us understand what all these 4 types are. The type 1 settling is known as discrete particle settling, and in this the particles settle individually without any interaction with the neighboring particles. The flocculent particle settling is what happens when one or more particles come together, they flock together. Because of that, they increase their weights and then they settle down because of gravity. Now, the third type of settling is zone settling, which happens as a zone, and particles in that zone will retain their fixed positions, and the whole zone will settle as a individual particle. Then compression settling. Now the concentration of particle is so high that sedimentation can only occur through compaction of the structure. This type of compression settling we can find at the bottom of the settling basin, and the zone settling, which happens just before the compression settling. That zone comes and settles down, and more compaction will occur, and the compression settling will come into picture. Now, the sedimentation tank types. Now, the sedimentation tanks can be either be intermittent or continuous based on their operation. And for intermittent tanks, are those tanks which store water for a certain period and keep it in complete rest, while the continuous tanks, they don't restrict the flow of incoming water, but a baffle wall is given in the tank, which allows the remaining part of the tank in which water is stored to be at rest. Because for sedimentation to happen, the water should be at rest. And based on shape, the sedimentation tank can be circular or rectangular. This is the figure of rectangular sedimentation tank, and this is the actual image of rectangular sedimentation tank. This is the circular sedimentation tank, and this is how it actually looks. Now, what all factors are affecting sedimentation? It is BOD and TSS removal. Now, if you want to remove BOD and TSS, then it will take longer time for sedimentation to happen. And short circuiting and hydraulic stability. Now, what is short circuiting? It happens when the incoming water directly without treatment escapes the treatment tank. So then that is known as short circuiting. And if this thing happens, then sedimentation will not occur at all. Then temperature effect. In the temperature effect, what we find is that the top surface of water will get heated up, and there will be temperature differences because the lower portion of water will be at lower temperature. So this will affect the sedimentation. And the wind effect, how it affects the sedimentation is that due to strong winds, there will be turbulence in water, and it will not be at rest, and sedimentation will take longer time. Now, what is coagulation and flocculation? Now, sedimentation can occur in two ways, like it can be plain sedimentation or it can be sedimentation aided with coagulation and flocculation. Mainly this process is used for colloidal particles which are difficult to settle because they are charged particles, and because of the charge they repel each other. So particles cannot come together, cannot aggregate, cannot form flocks, and their weight won't increase. So sedimentation won't occur. So for that, we had to add some coagulants, mix it with the water, and then flocculation will happen. Particles will aggregate and then increase in weight, and the sedimentation will occur. Now, jar test is a laboratory procedure to find the optimum dose of coagulant. Now, this is a procedure done in the lab so that we can come to know about the optimum dose which is to be used for actual wastewater treatment in treatment plants. Now, in this experiment, the pH can also be varied, the coagulant dose can be varied, and then we can find out the optimum dose. Now, this is the diagram of a jar testing apparatus. It consists of 6 containers of 1 liter each, and one container will act as a blank, and the paddles are given in the apparatus which we can be used to stir the contents of the container. And the RPM gauge at the top center of the device, it allows for the uniform control of the mixing speed in all of the containers. So how to perform this test? We'll see the procedure. Now, first of all, the jar test apparatus are to be filled with sample water, and one container will be used as a sample control, while 5 containers can be filled with the sample wastewater. And the pH of the jar can be adjusted, or variation of coagulant doses can be added to determine optimum dosing operating conditions. Now, the coagulant is added to each container and it is stirred at approximately 100 rpm for 1 minute. Now, this rapid mixing will help to mix the coagulant throughout the container. Then the stirring speed is reduced to 25 to 35 rpm, and the mixing continues for 15 to 20 minutes. This slower mixing helps promote flock formation by enhancing particle collision, which leads to larger flock. Then the mixers are turned off and the containers are allowed to settle for 30 to 45 minutes. Then the final turbidity in each container is measured and a graph is plotted of residual turbidity versus coagulant dose, and from that graph we can find out the optimum dose of coagulant. So this is how the jar test procedure is used to find the optimum dose of coagulant.